Our next speaker today then is Forrest Senti from Intelligent Payload Solutions, speaking to Embedded Credential Protector for frontline credential verification. Forrest?
Perfect. Thank you, Chris. Like Chris said, my name is Forrest Senti. I'm the Director of Commercialization here at IPS. And a quick fact, as we kind of jump in, there's two things I wanted to share with y'all. A lot of my background, I've done a lot of emergency management work in cyber, so some of my uh, kind of pieces I'll bring into this, not necessarily from first responder perspective, but generally speaking, emergency management. Alongside that, our founder, Chris Franz, who will be on at the end to help with questions if needed. He's got over 20 plus years of between firefighting and EMS kind of work, that has helped kind of with talking through some of these things before we all moved in the software land. So feel free to ask lots of really tough questions about wildland fighting, so we can mess with our CEO when he comes on later, because it'll be fun, right? Everybody likes a challenge. So to kind of jump in to kind of what we're going to talk about today, there's two things. First off, problem. The second thing we'll talk about is the technology in terms of the baseline that we're talking about, and then we'll get into kind of what we're here for to talk about embedded credential protection. When I look at the problem landscape, broadly speaking, driver's licenses are the most common form of ID credential worldwide. It is also the most likely to be defrauded. For 20 bucks, you can get fake IDs from China now, other countries around the world. And alongside that, when we look at things like verification, especially manual verification, oftentimes what we're doing is we are manually verifying. We're maybe looking for some holo printing, we're checking the ID. But the biggest thing there when we're looking at IDs is we're just looking at it at surface level unless we have some kind of barcode scanner. And in an emergency situation, anybody who's been familiar with some of the emergency management best practices, credentialing is an important part of the process. And one of the big things there in an emergency situation is accurate and rapid verification. Who are you? Why are you here? What certifications do you have? Who sent you? What's your purpose? Where am I supposed to assign you? I mean, there's all kinds of things that are happening rapidly. Here in our own community, we had a wildfire several years ago that, hurt over 150 homes. We had people coming from all over the region for this fire. And we had I think over 35 different jurisdictions coming to one location to help fight a fire. Imagine the credentialing systems and the different things you had to do in person physically without attaching to anybody else's registries to be able to do this type of work. So when I look at the bottom there, this idea of little to no integration between relevant systems for issuance, verification, tracking, verifying credentials, all that kind of stuff doesn't really exist a whole lot unless it's been preordained through a national network, for example. And the last thing I'll touch on here when we talk about our problem that we're focused on, secure connectivity. You're not always going to have this in emergencies, especially when you're in a remote location. So one of the big things for our work is we put a big focus on this idea of offline. What can we do offline in these situations? So to kind of level set too, in terms of who can benefit from our product, a lot of our research was really heavily focused on things like National Registry of EMTs, the Emergency Management Assistance Compact, FEMA, but really any first responder who deals with credentialing and emergency management type scenarios might be interested in our product and kind of what we're here to talk about today. So to kind of talk a little more about the technology as a primer. In today's world, most driver's licenses have these 6 elements. Things like a barcode on the back. They have a UV element where you can shine a light on it and you can see some stuff on there. There's things like microprinting, laser engraving, special inks. But the reality of the IDs today is there's really a lack of redundancy when things like the internet is down. You have to have specialized equipment to be able to verify them on site. And ultimately, there's only a limited amount of data that you can put on these things. And because they're used at the state level historically, it's kind of difficult. Relatively speaking, with the exception of maybe people who aren't supposed to be driving, there's not a lot of information sharing going on between state governments on kind of what the background is of some of these people. When you layer that in with how a lot of you probably get your credentials done today, it's very similar, but the reality is there's limited external connection, and they're relatively easy to fraud. Like just now, you can't really see these very well, but there's a stack of IDs right there that I got printed that are scannable with faces and all kinds of stuff that you could use in a situation if you wanted to defraud something. It was easy. It cost me $22 to get that done. So it's one of those things where how are you preventing it? How are we working against that? So these are the requirements we really wanted to focus on after we did all of our research in this whole space. So the first one, state and local first responders can accelerate interagency credential verification. One of the big things, like especially in this case, like with the incident commander, when people are coming into the situation, you're trying to identify what they're here for and what they're trying to do. how are we working to accelerate that credential verification? What does that look like today? And how could we make that better? The second one is verification speed and accuracy. You got people coming on scene. You want to make sure you understand them as quickly as possible. What do? How do you accelerate that process where you can get somebody to get in and do the work that you want them to be able to do? The third one is, let's say you're in an emergency situation, your own house burnt down, but you're trying to come and help still. But all of your identification is gone. You have nothing physical. Well, nowadays in several states across the US, we're getting, it's more common for either workplaces or your state government to issue a digital ID. So how could we also work with a digital ID that has something similar? So those three were kind of the basis of what we were thinking through for today's presentation when we talk about these requirements and kind of the technologies involved and all that kind of stuff. So now let's talk about our product, Totem Boss. At the very beginning, you heard our title. We're the embedded credential protector. So what does that mean for this context? Ultimately, what we do is we covertly embed credential holder data in an image. So if you look at the left side there, there's a Colorado driver's license. If you look at the bottom left side, there's a similar driver's license. What's the difference between those two? Well, the difference is that through our API, which I'll show you on the next slide in a little bit, we're able to basically embed data using something called stenography into the image of that person's face. You can't see it, you can't detect it. It's almost impossible for you to quote unquote hack it and get that information off of it. And because it's unalterable, there's lots of data that you can add in the background, lots of pointers, lots of different things you can do to change a lot of the different background information. So this whole thing, this behind the scenes system can exist without anything else there. It's just what's on that image. And then through our verification process, it's essentially just a phone, uses an app, you scan it, and it tells you if it's valid or not, and then it can decode it and pull the information off. And this is all API driven, so it can be integrated in multiple different ways, not just for driver's license. It can be any badging. It can even be like a physical record, like a document, for example. But the idea is, it really is about highlighting the ability for you to protect something and add credibility to it, but also allow you to verify it on the spot at any given time. And it works offline, so that's a good function. In terms of our user flow and kind of how this whole thing works, essentially, where we would plug into anything is at the issuer process right here. So at any point you're doing an issuing process is kind of the major place that we would kind of plug in and help you. And if you follow along kind of here through our background here, this is kind of how it all works. The API gets called, it goes through an entire registry, it takes the image, puts essentially what we consider a stamp on it, and then that stamp has pointers that reach out to a different registry and allow us to then, all behind the scenes, using an app to scan it in the same way when somebody's presenting and trying to get verified. It's a relatively simple system, but it has big impact, and that's kind of the fun part. And when we start to think about some of the different features and some of the different things, we like to really focus on these 7. The first being it's covert. Like I said earlier, it's not human readable. You can't see it or make it obvious to the naked eye, but it's there, I promise you. The second one is it's personalized. We can create a unique one for every single credential, especially with unconnected verification. So you won't have 2 of the same. So there's no issues there, because theoretically you could take somebody else's barcode. There's other things you could do in that space, but not with our tool. On the security side, you literally can't decode this with public tools. Encoding isn't reverse engineerable. We're working on testing now where we can prove that even further, but you would have to have intense brute force type of computing resources to attempt to attack something like this. And theoretically, you'd only be able to do it on one ID, not all of them. So in terms of independence, things like connectivity, being unconnected, being unique, all that kind of stuff. One of the big things there is each issuer's design can be distinct. So we can stamp that anywhere. Right now, we focus on the face because that's where most people think it should be. But theoretically, it could be in the bottom right-hand corner of an ID if we work with you correctly. Or even a piece of paper. It could be an instant credential, a digital credential, anything. So it's a dream, essentially. On the connected and unconnected side, it really is designed to include the connection to the DIDs, because that's all about being immutable, flexibility, being able to get to it. We can architect that however you want to. On the unconnected and unique side, it really is about credential verification, ideally without internet. So it works pretty well. And then on the unique side, we can use a lot of proprietary elements for critical security, but we have open elements for ease of implementation. So we're pretty flexible. When we look at the competition, Anybody in the identity space knows about IDEMIA and Talus and what they offer. There's a few other ones like Giuseppe and Devant and De La Rue, but a lot of our focus is really on that offline function and the ability for it to be covert. And we use a really high amount of cryptography when we work with our application as well. And it's inexpensive when it comes to the equipment you need. In terms of where we're at today, last fall we had a heavy focus on getting the interface complete with the API, doing things like bulk testing. Earlier this year, we got the mobile application done, so we can authenticate now with or without data. You just have to download all of the different things you need locally. Early in the spring, we've been focused on strengthening the core algorithm to TRL6. So we've got over 30 variants that we've completed and tested. Right now, we're just focused on tuning for different light, if you put a sleeve on it, for example. So we're working through a lot of that now. But it's a demo-ready product. So if any of you are interested in getting a demo, please feel free to reach out. We can always work with you on a use case, because that's the fun part, is actually getting it implemented, right? And again, just for quick background as I begin to kind of close out my presentation today, IPS has a history of commercializing different technologies. We've been around for about 18 years, but we're always confident in our ability to commercialize. So please feel free to reach out. Last slide here. These are kind of our engagement goals. We would love to work with you and have more conversations on what specific needs you have if something like this will work for you. Always want to learn about your use cases. As a new product for us, we want to learn where this fits, and that helps us grow, helps us create more jobs, all that kind of fun stuff. And the last thing is the contract vehicles. If you're in the federal space, we can always do an SBIR kind of a data option kind of thing. And those in the Fed space understand what that means. So feel free to reach out. But in close, my name is Forrest Senti. Thanks again for having us, and would love to answer any of your questions.